All right, a little bit of a graphing review here for graphing polynomials, and only two problems. Let's start with the first one. Mia remembers that she can quickly find many features of the graph of a polynomial function when it is in factored form. Help her find those features and then sketch a graph of f of x. Problem number one. We want to find the x-intercept of f of x and the multiplicity of those x-intercepts. So let's remember, multiplicity means how many times does the factor for that 0 appear. So multiplicity is number of times the factor appears. Okay, so we look at we look at function f here, and sometimes for the multiplicity, it's easier if we write it instead of having a factor squared, we write that factor the number of times. If it's squared twice, if it's cubed 3 times. So a lot of times it's easier if we go ahead and expand this function out. Now I have this factor x minus 4, but since it is squared, I know that I have to write that factor twice. Okay, so now to find the x-intercepts, the first x-intercept is going to come from this first factor of x plus 1. So if we take x plus 1, set it equal to 0, and solve, we get an x-intercept, or 0, of x equals negative 1. Then when we take this next factor, x minus 4, set it equal to 0 and solve, we get an x-intercept of 4, or a 0 of 4. And then notice that that appears twice. So this x equals 4 is going to have a multiplicity of 2. Okay, now we want to find the y-intercept, and finding the y-intercept, a lot of times it's also easier to have the function written out. So I'm going to rewrite the function down here. F of x equals negative 2 in front, x plus 1 times x minus 4 times x minus 4. And if I'm looking for the y-intercept, I need to imagine what happens when I put zeros in for x's. And when I do that, I'm going to end up with this negative 2 in front times a positive 1, because 0 plus 1, times a negative 4 times a negative 4. When I multiply this out, I should get negative 32. So 2 times 1 is 2. Negative 2 times 1 is negative 2. Negative 2 times negative 4 is positive 16. Negative 2 times negative 4 is positive 8. And then positive 8 times negative 4 is in fact negative 32. So my y-intercept is at negative 32. Okay, if you want to write it as a point, it is the point 0, negative 32. If we wanted to write these x-intercepts as points, obviously negative 1, 0, and 4, 0. Perfect. Now we want to identify the degree and the leading coefficient. The degree and the leading coefficient. So when we find the leading coefficient, what we need to do is we need to imagine what's going to happen when we multiply all of these x's. We got an x times an x times an x. But we also have everything multiplied by negative 2. So my first term should be negative 2x cubed. So the degree of my function should be a degree 3, and my leading coefficient is a negative 2. So how does that help me with the end behavior? Remember, when the degree is odd, that means my tails go the opposite direction. And with a negative leading coefficient, that means it's overall going to have kind of a negative type slope, starting very high on the left and going down low on the right. Now we want to take all of this information and we want to sketch a graph of our function. We have our first x-intercept at -1. We have another x-intercept at 4. Remember, that one has a multiplicity of 2. And then we have our end behavior goes up on the left and kind of down on the right. Now we just need to, one more thing we have is our y-intercept of -32 down here. So here are all the important points. Now it's just a matter of connecting the dots. So to sketch this function, I know that this 0 of -1 had an odd multiplicity, right? So it goes straight through. Then it crosses over the y-intercept. Then it comes up here. Remember, +4 had an even multiplicity, so it acted kind of like the parabola here, so it bounced and then came over here and continued down on the right. So there is a very sloppily done graph of this function. All right, going on to problem number 2. Same idea. We're looking for x-intercepts, find the degree, and eventually sketch a graph. So here we go. The y-intercepts here. Remember, the y-intercept of g of x is always the constant at the end. So my y-intercept is going to be -6. So there it is in the point form, or you could just as easily write y-intercept. The y-intercept is at -6. Identify the degree and leading coefficient. Well, the degree, we look at the power. So here I have a degree of 4. And my leading coefficient is the coefficient of the first term, and it is 5. So my leading coefficient is 5. So my end behavior, since it's an even degree with a positive leading coefficient, I know that the tails are both going to go up. Now, the degree can also help us predict how many x-intercepts the function will have. So I think that this function should have, with a degree of 4, I should expect to see 4 x-intercepts. So 4 x-intercepts. And remember, that is a big maybe. That may be the case. If we were to factor this polynomial function, if we could factor it and find any even multiplicities, that would change the number of x-intercepts, in addition to the fact that we may have imaginary zeros. So we're not really sure. So now take all this information and sketch a possible graph. So first I have a y-intercept at -6, so I can plot that point. I know my end behavior, it's kind of going up on the left and up on the right. And that's really all I know. I do know that at some point this has to have at least 2 real zeros. It should touch the x-axis at least twice, because it has to be above the x-axis on the left. It has to go below to hit my y-intercept of -6. Then it has to end above my x-axis. Anywhere else in between here, I'm not really sure. So what we could do is just throw in a couple of bumps. And there's a possible graph. That doesn't mean that that's definitely what the graph looks like, but that is certainly a possibility for the graph of this function.